Good morning once more. In our previous class, we looked at dependency injection, which you said is a design pattern, which can simplify so many things. We implemented a simple DI container and all of that. So today we'll be looking at core Node.js. So we'll be diving into the Node.js philosophy and design fundamentals. So under core Node.js, our objectives for today will be to understand the Node.js philosophy and design patterns, understand asynchronous control flow patterns as well, and asynchronous code handling. We also get to introduce the callback help problem and provide solutions to it. So in order not to waste our time, and we'll move straight to Node.js philosophy and design fundamentals. So the core philosophy behind Node.js was built on several key principles that distinguishes it from traditional server-side technologies. So one of them was the event-driven architecture. So Node.js uses an event-driven non-blocking input and output model that makes it lightweight and efficient. So what this simply means is it registers event listeners and then also emits events. And one of the Node.js philosophies, it was also built on it's single-threaded event loop. So Node.js runs on a single thread, but uses an event loop to handle multiple operations concurrently. So it's not JavaScript, or should I say Node.js? JavaScript is a single-threaded programming language, but Node.js introduced event loops that handle multiple operations concurrently. So the operations are not they do not block the IO. So what if you make like 2 or 3 operations, they'll be handled separately without blocking the IO. So moving to the third one, we have the fourth one actually, the non-blocking IO. So before Node.js, or should I say prior to Node.js, traditional blocking versus Node.js non-blocking approach. So there are asynchronous operations and synchronous operations. So when you perform synchronous operations, they block IO and they'll have to complete before any other thing will be done. But when it's non-blocking, while it's running, should I say, under the hood, other operations are being carried out. Something like that. So you have something like, for example, let's say you have Okay, so let's say, for example, you have zoom in. Okay, so let's create an index.js file here. So in here you have, let's say for instance, we have the FS inbuilt module. So you say import FS from Node FS. Or basically this should be const FS is equal to require Node FS like this. So if you do something like const read file is equal to FS read file sync. So this is a synchronous, okay, read, not read. So this is a synchronous operation. And before any other thing will be operated on, this we have to complete. So if you read a file synchronously, you have to read the file before proceeding to any other operation. But if you use read file is asynchronous. But instead of saying read file async, that doesn't basically make any sense. So it's read file, and the synchronous version is read file sync. So if you do something like this, you're actually not blocking the IO. This is the Node.js way. And the read file sync is actually the traditional way without Node.js. So Node.js introduced the non-blocking IO. Next on our list is the module system. Node.js also uses common JS module system. And now it also supports ES modules out of the box, especially in this version major release, the version 23. It supports ES modules out of the box and also TypeScript. Okay, so we already discussed what modules are. We gave some examples. So now that we understand the core fundamental, the design fundamentals behind Node.js, we proceed. We discussed briefly about the core philosophy, the event-driven architecture, the single-threaded event loop, the non-blocking IO, and the module system. Now there is a minute, please. Okay, so we'll look at asynchronous control flow patterns in Node.js. So the first one here is the callback pattern, which we've been using. So let's, for instance, say we want to fetch user data. Let's, for instance, say we want to fetch user data. Yes, we should rename this to callback. Let's, for instance, say we want to fetch user data. So we'll write a function that does that, a function that fetches user data, function fetch user data, which takes in the user ID and call back. takes in the user ID and a callback function. So in the function body, we simulate database operation that fetches a user's data. So we'll say set timeout. We'll pass in a callback function and time in milliseconds. That is 1 second. You see if user ID, let's simulate an error here, is invalid. We want to return the callback we passed as a parameter. Then we'll call the callback with new error, and we will say invalid user ID. Then the second argument to this callback will be null. Okay, so the reason why it's okay, not in the error, the callback. No. I will see the reason why we're passing two arguments to the callback function actually. This is JavaScript, this is not TypeScript, even though we've written types and we actually know what to pass as arguments to this callback function. But now let's say we have our user data. Sequence user data now is equal to ID. You see it's the user ID they've passed as an argument. The name is John Doe. Email should be john@doe.com. So we have this user in our database. So now that there's no error, we want to actually return the user. We'll say callback. No, there's no error. So the first argument to this callback will be no. And the second argument will be the user data. So we have our fetch user data, set time out, say the user ID, if it's invalid, pass two arguments to our callback. We'll return our callback function with error and data will be null. But if there's no error, we invoke our callback with the first argument of null, second argument of user data because there's no error. And we'll see why, in a bit, if there's no error, null is the first argument, and if there's an error, the error is the first argument. So how do we now use our function? So let's say we want to actually fetch users. We want to use our function to fetch user data. So fetch user data. Now we'll pass in user ID of, let's say, user 90. Then we'll pass in a callback. This is the callback function we're passing here as a parameter. This callback, it's the one we are passing to this fetch user data as arguments now. But as you can see, we are passing two arguments to this callback function. So it will take two parameters here. So we have error and data. And now you see why, if there's an error, the error is the first argument because the error is the first parameter here. If there's no error, null is the first argument because there's no error and data is the second argument here. So in the function body, you say if error, we first of all handle errors. If error, we log the error to the console. Error fetching data or error fetching user. And then we say error.message, something like this. Then we'll return. We don't want to return the error. We just want to log the error, then return without proceeding because an error occurred. Now, but if there's no error, what we want to do is log the user to the console, user data, see data like this. Okay, so let's say node callback JS. Okay, we cannot find module. Okay, this is should be callback. Okay, like this. Node callback JS, and after 1 second, we get back a user. And if you change this to 2 seconds, let's say the network is slow and our requests have decided to take longer than expected. So if you pass in 2 seconds and we run this, it will take 2 seconds and then we have our user back. Well, let's say we pass in an ID, an invalid ID. Go back. And this time around, we have error. And the error says error fetching user, invalid user ID. Great. So this is basically the callback pattern. Now you wrote this. This is a function to fetch users. And in this function, we pass in a user ID and a callback function as a parameter. So if the user is invalid, we return this callback with an error and the data argument will be null. But if there's no error, we invoke our callback with null as the error and user data as a data argument. And here, that is what we're doing. And because the user ID is invalid, we're handling our error. But if you pass in a correct user ID, user 290, and we run this, after 2 seconds, we have our user here. So that is basically the callback pattern. Okay, so moving on, we talk about the error first callback convention. The error first callback convention. So in the error first callback convention, let's say for instance we want to read a file. So Node.js follows the error first callback pattern. So you first of all handle errors. You first of all handle errors before proceeding to actually check for your data and handle your data. That's the reason why we're first of all handling errors here. So in callback pattern, that's normally how it's done. Even inbuilt functions like inbuilt modules like the read file. The read file takes 3 arguments, of which one is optional. So the first one is the file name. The second one is the encoding, which is defaulted to UTF-8, and a callback function. So the encoding is optional, but the callback takes parameters of error and data. If there's an error, data is null. If there is no error, error is null and data is returned. So this is basically what we are doing here. Error first convention. We're handling errors first. Even here, we're checking for error before and this, all of that's the error first callback convention. So moving on, we have the sequential execution pattern. So what essentially is a sequential execution pattern? So when operations must happen in order, that is what we consider this sequential execution pattern. Maybe you want operations to happen in order. You want the first one to happen before the second one, before the third one. So you have 5 operations and you want them to happen in order. 1, 2, 3, 4, and 5. You don't want 1 to happen, 5 to happen, 4 to happen, then 2 should. I know you don't want that. You want them to happen in sequence. So how do we go about this? Okay, so let's say we have a process. Let's say we have a process user. See, we should create a new file. Sequence exec. Yes, like this. So let's assume we have 3 operations that we want to perform at once, but in sequence. So let's say we want to fetch a user. They will take the user ID and a callback function. There's a short form of callback, .cb. You will set timeout, and in this timeout, pass in a callback function that actually returns the callback with arguments of null for error, and then the user data should be an object with ID. The ID of the user will want to fetch, and the name should be John. The name should be John, and the email should be no, not email. This should be a status of pending, like this. So we have another function. They will call this one, let's say validate user, that takes in a user and a callback function as well. So it returns error of null and true as a second argument. So we have another function. This should be update user status. So this one takes in ID of the user, the status of the user, and a callback function. So what it does is it returns the set timeout callback function returns the callback with the first argument of null and the second object of ID and status. Status like this. For this time around, we are not passing time to the set timeout function. So let's see. Oops, what am I doing? Let's say each of them should happen in, let's say, 100 milliseconds. It should happen in 100 milliseconds, so it doesn't take time. So these operations should complete, all of the operations should complete in 300 milliseconds. So now we write a function to handle these operations in sequence. So this function name will be function process user workflow, which takes the user ID and a callback function. Now let's log to the console and see starting. This should be user workflow, something like this, starting user workflow. So now I want to fetch the user first. Say fetch, fetch, what am I doing? Fetch user. And the fetch user takes in an ID and a callback function. So since the process user workflow takes in a user ID, we just pass it as an argument to the fetch user function, and a callback function with a parameter of error and user. So what is this function, callback function doing? So if there's an error, it should return callback of error. But if there's no error, okay, we say console log user fetched. And then we'll log user name like this. So now that we fetched the user, what do we want to do? The next thing is to validate the user. So where do we pass the validate user function? Inside the fetch user function. So say validate user. And this validate user function takes in the user that we fetched with the fetch user function, the user, error, and is valid property is valid. So what are we doing? So if there's an error, so let's just copy this and paste it here. If there's an error, we handle the error. If the user is not valid, if it's valid, what do we want to do? We want to return a callback with an error. It's a new error. Say user failed to validate user, like so. But if the user is valid, we just log to the console. Let's say valid user, like so. So if the user is valid, so what next do we want to do? We want to update their status. So if the user is valid, inside of the validate user function, this way we update the status. So we call update user status. So this takes user ID, say user.id, and the user status, the status we want to change it to. So we say active. So the user, here we have a user that is actually, where is it? We have a user that is pending. Okay, so this is blocking me. So we fetched a user here and we have the status of pending. So the user is valid. Now we want to update the status to active. So come over here, we'll pass callback with an error and result. So inside of this, if there's an error, we handle the error first. But if there's no error, we just log to the console and user status updated like this. And then what do we want to do? Callback. We invoke our callback with first argument of null because there's no error, and user. So update the user. We say user. Then we say status is completed like this. So if you come over here and invoke our function, okay, pass process user workflow. So this is our process user workflow function. We've not invoked the function actually. Process user workflow. we invoke our function process user workflow, takes in user 190 and a callback function with error and data as parameters. So if error, callback, if error this time around, why not? This is a final this thing. We just log error. Say error dot message. Error, okay. Error dot message. But if there's no error, they will log data to the console like this. User editor. Okay. Okay, so let's execute our. I'm executing another file. Sequential execution JS. Okay, so we can see what we have here. We have starting user workflow. Now the first one that ran was the fetch user, which said user fetched, and the name is John. The second function that ran is the validate user. We validated the user and we say valid user. The third one is update user status. User status updated, and then we have our final user with the ID of user 190, the name of John. The status is pending. Okay, status is completed. Let's change this to, we pass in the user and then we'll update the status to completed. Okay, so now we have status completed, no longer pending. So this is sweet. As you can see, these functions now run sequentially, but this is leading to what we call callback hell. So we are calling functions in other functions, which is becoming harder to read, and this will cause debugging and testing issues as well. So this is how we can do this sequentially. So how do we do this? Let's say, how do we do this in parallel? Asynchronous control flow patterns is also parallel execution. So how do we execute this in parallel instead of sequential, using sequential execution? Yeah, Sakib, go ahead. Yeah, you can go ahead and ask your question, please. You raised your hand. I thought you wanted asking something. Because I can't hear you. Okay, I can't hear you. Maybe it's your network or something like that. Okay, so
Can you hear me now?
yeah, I can hear you now.
Okay, yeah. So my question was that the last function is the function that handles the sequence by which all of the other functions run.
Yeah. Okay, so you mean the process user workflow, right?
Yes.
Yes, because these are just functions, and for them to run, we have to call them or invoke them. So we are invoking them sequentially in this process user workflow function. And after that, the user workflow function is also a function on its own. So we have to invoke it, passing the arguments that appropriately represent the parameters. So the ID and the callback.
Okay. Thank you.
Yeah. So now we learn how to do this in parallel instead of It's a parallel execution. Yes. So let's say we want to fetch all user data, but we want to do it in parallel, not sequentially. So how do we go about this? So see, we have a function that fetch all user data. It takes in user ID and a callback function. So first of all, we will be writing some code here, but after writing it, we explain. So we have variables here, two variables and one constant, a variable of completed, which is equal to 0. Another variable has error, which is equal to 0, and a constant of result, which is equal to an empty object. So the operations we want to perform are, we pack them in an array. So we say const operations. This is equal to an array. And this array we have name. Each operation we have a name, which we basically serve as the key. So we have a name of profile. And the function here, the function we want to execute on that operation will be, this one will be, let's say, fetch user data. We've not written this function. This is a comma. We'll have another object in this array because we want to execute this in parallel. The next operation will be to fetch the post. The key here will be the post. And the function we want to execute when we get to this level is fetch user post. Oh, this is the name, not just post name. And we'll have another one, which the name is, let's say, friends. Let's say it's a social media app. Then the function we want to execute here is fetch user, let's say fetch user friends, like this. So since we want to do this in parallel, what we're going to be doing here is to say, we have an array of operations. They will say operations, then we write a for each higher order function that take in a single operation. So for each single operation, what it will do is it will execute the operation function. So we say operation dot fn, that is the function. So we call the function, we pass in user ID, and let me just stop here and come and write this function so we know what we're actually doing. So we have, let me write it at the top. So we have function of fetch user data, which takes in user ID and a callback. So inside it says set timeout, the callback function of that returns our CB. First argument is null, and the second one is the user ID object with the user ID, username of John, and age of 29, like this. So this should execute in 200 milliseconds. This should execute in 200 milliseconds. So copy this one here, bring it over. Then we'll rename it to which other one? Okay, fetch user post. Fetch user post. So this will take the user ID and a callback, but it will return an error of null, and the user post will be an array. Let's say post 1, post 2, post 3. So we will now fetch the user's post. So this other function here will be fetch user. This one will be fetch user friends. So what does the fetch user friends take in? This will take in the user ID. So we can use the user ID to get the user friend. So in here, we see this should return user friend of Kent and Josh, like this. Okay, but these functions, they will execute at different times. So this should execute in 300 milliseconds. This should execute in 150 milliseconds, like this. So now that we've written our utility functions, it's time to use them to perform our operations. So for each function here is taking a user ID and a user callback. A user ID and a callback function. So as you can see, each of them here takes ID, and a callback parameter. So we pass in user ID as an argument and a callback. So what should the callback look like? Now, the callback will take error is always the first parameter and data is the second parameter because we are first of all handling errors. Now we say if has error, we just return. We will not do anything. We do an early return because it's an error. Oops, not this kind of error. Return like this. If the if has error, we return. But if there's an error in the in our callback function, the error parameter we just passed. If there's an error, what do we want to do? We see has error is equal to true. Has error is equal to true, and then we return callback error. As you can see, in some cases, I will just pass the error error argument without the data because data is second. You can pass something like data, or you can pass something like null. It's still the same thing. Because in this case, when you pass the error, remember the null here is you can actually come over here and say error is equal to null, something like this. But this doesn't make sense because it doesn't really make any sense. But if you don't pass the null here, error will be undefined. So undefined evaluates to false. So if you check for error, error is undefined and this block will not be executed. So it is the second, since it's JavaScript, this is not TypeScript. The second parameter here is should I say the second argument to the callback function is optional, which is the data. But by the time you want to pass in data, you cannot, arguments are passed in a function in the order in which parameters were defined. So we have error and we have data. So the first argument must be the error. So if you want to pass the data, you just pass null, saying the error is null and then the data. But since it's only the first one you want to pass and the parameter is not an object, what you will do is just pass in the first argument to the function and ignore the second one, which we default to undefined. Okay, so since we have the result object here, if there's no error, we'll say result, and we'll grab operation, we'll grab the operation by the key, then we say it's equal to data. Oops. Data, like this. And after doing this, we say completed plus plus. We increment the completed count, and we'll see the reason why in a bit. So after this, we check below, you see, if completed is exactly equal to operations dot length, what do we want to do? We just want to return the result. We don't want to perform any operation anymore because we've performed all the operations. We just want to say call back with, there's no error. We just want to return the result like this. Wow. So we're getting there. So let's try to fetch all user data and see what we've got. So we'll say fetch all user data. And this is taking an user ID, say user 34, and passing a callback error data. And this callback will say, okay, if there's an error, we just want to log the error to the console. Say error dot message like this. And then we'll do an early return. We don't want to go past this level because there's an error. But if there's no error, we'll just log all user data. And then we log data like this. Wow. So let's run our function. Parallel exec JS. So node parallel exec JS. Okay. So why are we getting an error here? Cannot find module parallel exec. Parallel exec. Okay. Result is not defined. Okay, this should be result. So let's run it once more. Okay, so now we have, you can see how they are processed. Even if we have the fetch user data, which we execute in 200 milliseconds, which is more than 150 milliseconds, we can see that it actually worked because we have the post. Where is the post? 150 milliseconds. We have the profile. The profile here is which is the fetch user data. It's 200 milliseconds, and we have friends, which is 300 milliseconds. If you come over here and change this one to 100 milliseconds, and you execute this, this is sequential. This is in parallel, not sequential. So if you execute this, you see that the friends comes first, the post second, and the profile last, because the profile will execute in 200 milliseconds. So these are executing in parallel. So let's assume you have you are making a network request. So this network request will take longer than this one. This will take longer than this one. This essentially it's a kind of promise.all, which executes in parallel, not sequentially. So if you want to execute in parallel, this is basically how you go about it. But we don't have to do all this anymore because ES6 has come to our rescue. Wow, so this is how to basically handle parallel execution in Node.js. So moving on, we have asynchronous code error handling. So under asynchronous code error handling, we have try-catch limitation with async code, error propagation in callback chains, and global error handling. So let's first of all look at try-catch limitation with async code. So in the traditional approach to try-catch doesn't work, or it doesn't work with callbacks. So the traditional approach doesn't work with callbacks. And let's see how it should be async error JS like this. Then we have function. bad error handling, because this is a bad one. It will not work. So in here we have try a try catch block, and then we have something like let's say we want to read a file. We have something like fs read file, okay, read file, and in here we pass the file name and a callback error data, and then we try to, if we say if error, we say log error or something like that. So this will not work. This here, this error handling here will not work. And if you come over here and say log error, this will also not work for async operations. This will not work. So the correct way to do this is to remove this try catch, do this thing, check for error, and then handle your data successfully. Say data. So this is the correct way to do it. But if you use a try catch, it will not work. Remove the try catch, handle your error in this callback, and then process your data. That's how it's being handled. Okay, so moving on, we have error propagation in callback chains. So how do we propagate errors in callback chains? So let's see how we can properly propagate errors through callback chains. So let's see. Okay. So basically, we've kind of done. I'm trying to come up with a simple example that will teach us how to propagate errors. Okay. Let's look back at sequential. Okay, so look at what we're doing. If there's error, we are returning the callback with error. So we're just propagating these errors and then we're handling it here. Let's assume we have any errors. They'll be propagated to this point, and then we'll handle our errors and then log them on the console. So as you can see, if you have any errors, instead of logging them here, we are returning the callback with those errors. We don't want to handle them here. Then we're propagating them to this process user workflow. This is where we're capturing them. So that's basically error propagation in order not to waste our time. So the next on the list is global error handling. So for global error handling, we can do something like, and we'll do more on this later, because right now more on this global error handling later. So we'll see let's say we're running a Node.js app, and then we want to handle on caught exception or unhandled rejection or sig term, like the control C and the other ones we do. We want to stop a server. You see, we're running a process. We say process on process on. Then we say this should be on caught exception. So this will take in the error because there's no data. This is only the error. And then we do whatsoever we want to do with the error. So we can go ahead and handle another one. We have different errors. We can call this one unhandled rejection. Unhandled rejection. And we can even handle our other ones. We have this one, we can call it sig term. like this. And all of that. So this is basically how to handle global errors. But more on this maybe in our next class, or we want to build a basic Node.js server to talk more about global error handling. Okay, so moving on, we'll talk about the callback hell problem. So what is callback hell, and why is it a problem? So callback hell occurs when multiple asynchronous operations are nested actually, creating deeply indented and hard to read code. So we don't need to rewrite this. I guess we already have one here. It's not deeply nested, but it's good enough to show our example. So look at this now. So imagine you have 5 more functions that you want them to execute in sequence. Now you have this one is out. You have this one inside the fetch user. You have the update user status inside the validate user. Now, imagine you have another function that may be sent email to a user after the status is updated or something like that. It will be inside the update user status. So imagine you wanting to test this out. That will basically lead to a callback hell. So it will not be readable, because imagine you want to comprehend, you want to read 10 nested functions. That would be a kind of a problem to you. And so this is actually a problem. And why is it a problem? And what are the problems behind callback hell? So we have readability issues, error handling complexity, and debugging difficulties. So if you want to read this, imagine another person writes a function that have 10 nested functions as callbacks, and you are reading that code, it will be messy. Then error handling complexity. So just imagine how we're handling errors. Imagine how errors are being handled here. This is not a good thing. This error is handled inside of this one. So imagine there's no error here, but there's an error here. We get everything becomes so messy. It's not just advisable. So we have also debugging difficulties, right? So imagine we have 10, let's say we have a function that have 5 nested set timeouts. So if an error occur in the let's say the last nested one, let's say the 5th one, how do you trace where the error occurred? Like, so you start debugging and debugging and debugging. So that would be a kind of a problem to catch early. But it's a solution to the callback hell problem. So that is the callback hell solution. So the first one here is the name function and modularization. Modularization. The second one is control flow libraries. The third one is using promises, ES6 promises. And the fourth one is async await ES 2017, I guess. Okay. So the name functions and modularization. So we can basically instead of doing something like this, we write this function as a separate one. So after writing it as a separate one, instead of doing all this, we pass user data. Let's say we have this function outside of this process user workflow. Now, instead of doing this, we just pass the user, pass the callback, pass callback like this. Okay, so I'll have to do this. And inside of this validate user function, I will grab this, bring it inside not inside here, actually, it should be inside the callback, but I'm just dropping it here. And this, remove this one as well. Pass in a callback. Remove the validate user. Then you can bring the validate user inside the fetch user function. This shouldn't be in the body, it should be in the callback. So you call this in this in the then you don't have to come over here and start messing around with the process user workflow function. You call the fetch user will call the validate user, and the validate user will call the update user status. But that's just by the way, that is not the solution we were using, because that's still a kind of a problem. So the next one is control flow libraries. So we have a library called async.js. So we're not going to be showing some examples actually, but I think we should just take a look at async.js. Async.js. So here it is. So it's a clean, composable way to manipulate sequences of values with asynchronous functions. So helper function do callback of callback syndrome, do something useful. So instead of that, you just say with async.js, this can be written as async.list like this, and then .call.end. Then you handle your errors successfully and all of that. So we have features to call the filter, map, reduce for each, sum, every. We have the asynchronous versions of all of these. So Node.js file system plugin, we have the plugins for all of that. So if you want to use this, you can come to the library, take a look at the documentation, and actually get along. But the main solution here is, since we have ES6 at our fingertips and async await, there's no need for async.js, but we just need to know that named functions and modularization with control flow libraries can be a solution to callback how problems. So in promises, we don't really need to do something like that. So we can just come over here, so we'll see callback solution JS. So now that we've seen, I would say we've seen that we can use promises to solve our callback problems. Instead of doing all those nesting and nesting and nesting. So there's this you cannot do something like const fs is equal to require fs, and then you want to use this in a promise. It will not work. It will not work. You can only use this in callback functions. In callback functions in a traditional Node.js way. But if you want to use this, actually, you can do something like const promisify is equal to require utils. And then what you do is, instead of the read file, come over and say const read file sync is equal to promisify. You say fs read file like this. So now you can use the read file sync. This is actually not a synchronous operation, but we are just converting a callback base function to a promise that we can successfully use in a promise without any errors. So you can just come over here and say you want to write a function like this function validate data async. Then you pass in user data. Then you return a new promise that takes this is the executor. We pass in the executor that takes in parameters of resolve, executor function, resolve, reject. So this executor function now we had a validate user function, but the function is no longer here. This function now we just validate user. So it will validate the user. So this is reading it from another. So it will validate the user with user data and a callback of error and is valid. The function we had earlier. So instead of become if error, we return reject error like this. Okay, this is an arrow function. If error, we reject error. Else, if there's no error, we resolve is valid like this. So with promises makes things easier. So we don't have to go about writing callback and callback, inviting callback here and all of that. So this is basically how we can do. But if you don't want to do something like this, let's say fs fs slash promises fs slash promise. Yeah, something like this. So you can go ahead and if you don't want to promisify this, remove this one. Remove this one. And you can use this in a promise and it will still work. So instead of promisifying that, you can use this in a promise or async await and it will still work. So this basically how to do this with promises and you can experiment. There's no actual example to do this, but you can experiment with this. You can try validate. There's a validate user in this sequential. There's a validate user function. You can grab this, bring it over to our callback solution function, paste it here, and then try to run this function, passing the user data, and you see, in fact, where is the validate user function? Let's grab this quickly, bring it here, paste it here, then remove this update user function. We validate user. So we invoke our validate user sync. Then we pass in user data of name John. So let's run node callback solution.js. Okay, so we're not logging anything. So let's log the result to the console. Okay, this is actually a promise. So it's pending. So if you hover over this, you will see, okay, this one here, it's returning a promise. So you will see a top awaits. This should be basically async. Or let's just call this still pending. Okay, wait, dot then. Okay, let's see. Dot then. We have our result. Then we log our result to the console. So let's remove this outer console log. This is a promise. So we can even do away with this. Do away with this one. And now we should be able to see something. Okay, console results. This is RE. This one here. Okay, so now we have true because what we are returning here is true. So we can basically change this to name John. Then is valid. Will be true like this. So now if we user data, validate user data, user callback. So we can even remove this one here and then pass in user, the user we are receiving from the validate user. Then bring this user here as an argument. Now, if you run this, we see name John and this valid is true. So this is a promise. And as you can see, this is how we're handling it. There's nothing like passing in a callback, doing all of that. No. And this is just fine. Okay, so the next solution to callback a problem is using async await. So instead of doing all of this blah blah blah, all these things we've been doing, we can just say append this with an async keyword. Then we'll say const is valid is equal to await validate user, and then we pass in user data like this. Then remove this one here, comment it. Say if can do something like if is valid, we can just throw new error of user invalid like this. Is valid is void. Here we are returning Okay. Or let's do away with this. Make this, leave it like this. And instead of doing this, then something, we can do something like async process validate process validate function. And inside of here, you see const is valid is equal to validate user data async. And now you can grab this one here and pass it. Now you can check for errors if it's valid. That is when we throw a new error, invalid user, like this. You should throw new error, invalid user, async function. So this is when we throw a new error. But remember, this is a promise, so we have to await for it to be resolved. Await like this. Else we will log is valid to the console. Is valid. Then let's come here and say this one is async/await. And then this one here is promise. Then we can come down here and call our process user workflow. No, not user workflow. Process validate function. So let's now execute our file and see what we've got. Okay, so you can see we have the same results, but see how there's no callback here. Everything is just straightforward. So we'll have a function that validates the user. It takes the callback with, we can even remove this callback and do something else. But for the purpose of this, let's just leave it like this. So the validate user returns a new promise. And in this promise, it validates this user, the user data, passed to this validates async function as a parameter. So it takes this user data with a callback function of error and is valid. So if there's an error, it rejects the error, else it resolves the data, which is valid. It resolves it. So if you come over here and call this promise dot then, as you can see, we're not awaiting it. So we're just calling it dot then, we're waiting it to resolve. And if it resolves, we console problem. But if it doesn't, we have, if there's an error, we say dot catch, which we return an error, and then we log the error on the console. Like this. So this is how to handle errors here. As you can see, this one here. And if you want to handle errors here, we can do something like this. Try catch. Drop this one in here, and then we log the error to the console. So this is just straightforward and nothing more. So this one, we're just checking if the user is valid. That's the reason why we're trying this error. But in here, we're actually catching for unforeseen errors and all of that. What we're doing here, this catch, this is what we're doing here. The async, the try catch. The catch here is this one here. So we're catching error. So we can actually come over here and we're logging the error to the console, logging the error to the console, and all of that. So in here, we can even do something. We can make this look alike. See, if result dot, see, if result throw new error invalid user, else we will log, and let's change this to is valid so that it matches what you're doing. Is valid. This also is valid. So this is a promise. When it resolves, we get our data back. And when it doesn't, when it rejects, we get our error and we catch it over here. So if you don't want to use a promise like that, we just call another function, an async function, process our promise function inside. This validates data async, pass the data object. And then if its value is false, throw this error. Else, we'll console this valid. But if there's an error, we'll log the error to the console. So as is valid user, throw new error. Okay. Invalid user. Okay, so here I'm actually saying if it's valid, I should throw an error. And as you can see, look at what we're invalid user, and then we're logging the error to the console. So if you want to see, let me see. As you can see, we have error here. This one here. So when you throw this error, it will propagate this error to this block, this catch block, and then we catch it over here. As you can see, look at this error that I just logged. So it will propagate the error, same as this one. If you throw this error here, it will propagate this error to this catch block, and then we'll catch it here and do whatever we want to do with it. So this is basically how to use async await and promises instead of using callback and libraries to handle asynchronous operations. So today class have been amazing. We've learned how to used Node.js. We've learned how to avoid callback hell and all of that. So we've come to the end of today's class. So if you have any questions, you can go ahead and ask, actually. Any questions? So in absence of any questions, we'll call it a day.